So let us look at method called Riemann's method for finding the solution of a linear hyperbolic PDE. In Riemann's method, we will be finding the solution of a linear hyperbolic PDE subject to certain boundary conditions. So let us look at what is the solution using Riemann's method. A general linear hyperbolic PDE can be put in the form L of z equal to f of xy, provided it is reducible to canonical form, where L is a differential operator which is in the form dou square by dou x dou y plus a, dou by dou x plus b, dou by dou y plus c, and here a, b and c, they will be functions of x and y only. So an equation of this form is a linear hyperbolic PDE. Now we need to find out the value of z such that it satisfies this equation L of z equal to f of xy. For finding the value of z, so first we will define another variable w. So w will be having the continuous derivatives of first order with respect to x and y. So we will define a new function w, and we have the operator L. Now corresponding to the operator L, so I'll define an adjoint operator to L, which is defined by, so if you have the function w, so when m operates on w, we will get the value dou square w by dou x dou y minus dou by dou x of aw minus dou by dou y of bw plus cw. So this operator is called as the adjoint operator to the operator L. So we have the hyperbolic PD L z equal to f of xy, and for finding the solution we have defined a new function w and an operator which is called as the adjoint operator, and the operator നമ്മൾ define ചെയ്തിരിക്കുന്നത് ഇങ്ങനെയാണ്. Now let us look at the value of WLZ minus Z MW. So L of Z ന്റെയും MW ന്റെ value substitute ചെയ്യുക. So this is the value of MW. ഇനി LZ എന്ന് പറയുന്ന ഈ ഓപ്പറേറ്റർ നമ്മൾ സെഡിലേക്ക് അപ്ലൈ ചെയ്യുമ്പോൾ നമുക്ക് ഡോ സ്ക്വയർ സെഡ് ബൈ ഡോ എക്സ് ഡോ വൈ വരും, എ ഡോ സെഡ് ബൈ ഡോ എക്സ് പ്ലസ് ബി ഡോ സെഡ് ബൈ ഡോ വൈ പ്ലസ് സി സെഡ്. സോ സബ്സ്റ്റിറ്റ്യൂട്ട് that into this equation. So this is what we are getting. ഇനി നമുക്ക് ഇതിനെ ജസ്റ്റ് റീഅറേഞ്ച് ചെയ്ത് എങ്ങനെ എഴുതാൻ പറ്റും. So here CZW and minus CZW, that will cancel out. So remaining the second order derivatives വരുന്ന രണ്ട് term, then you have WA dou z by dou x plus z dou x dou by dou x of AW, then WB dou z by dou y plus z dou by dou y of BW. Now this expression can be written in the simplified form using the partial derivatives. So using partial derivatives, they can be combined as dou by dou x of AWZ minus z dou w by dou y plus dou by dou y of BWZ plus w dou z by dou x. So we have got an expression in this form. Now let me call this function to be capital U and this function to be capital V. So therefore we started with W LZ. So W LZ minus Z MW can be put in the form dou U by dou X plus dou V by dou Y, where these will be the values of capital U and V. And now let us apply Green's theorem to this. Okay, അപ്പോൾ Green's theorem apply ചെയ്യാൻ വേണ്ടിയിട്ട്, so we require a closed curve, so which is enclosing a particular surface area S. So let me take C dash to be the closed curve which is enclosing our given area S. അപ്പോൾ നമ്മൾ we assume condition like this. So നമ്മൾ എടുക്കുന്ന assumptions ഇതാണ്. linear hyperbolic PDE solve ചെയ്യാൻ നേരം നമ്മൾ Riemann's മെത്തേഡിൽ എടുക്കുന്ന assumptions ആണ്. So zx and zy, zx, zy and z, they are defined over a curve C in the xy plane. So you have a curve C on the xy plane, and our aim is to find a solution such that it satisfies or it passes through the curve C, and we are interested in finding solution. So the curve C lies on the surface which we need to find, and we need to find the solution which satisfies the point, or which satisfies a condition P of psi eta. So സർഫസിൽ ഈ പോയിന്റ് കൂടെ കണ്ടെയ്ൻ ചെയ്യുന്ന രീതിയിൽ, ആൻഡ് ഓൾസോ ഇറ്റ് അഗ്രീസ് വിത്ത് ദ കർവ് സി, നമുക്ക് അങ്ങനെ ഒരു സൊല്യൂഷൻ ആണ് കണ്ടുപിടിക്കേണ്ടത്. സോ വി ഹാവ് ദിസ് closed curve PABP. So this curve PABP, we call it as C dash. So the surface, given surface, which is our integral surface, that is enclosed by this curve C on the xy plane. So that is the C dash we are having. So C dash is a closed curve. So along a closed curve, we can apply the Green's theorem. Okay. So C dash is a closed curve which is enclosing an area S. Now let me take the double integral over S. WLZ minus ZMW dx dy. ഇനി നമ്മൾ WLZ minus ZMW എന്ന് പറയുന്നതിൻ്റെ വാല്യൂ dou by dou x plus dou v by dou y ആണ് കിട്ടിയത്. Now by Green's theorem, if my line integral is of the form u dy minus v dx, then by using Green's theorem, so in Green's theorem we will be taking, so if you have double integral, if you have integral m dx plus n dy, so this will be equal to double integral nx minus my. So in place of n we have u here, and in place of m we have minus v. So upon applying the Green's theorem, we will get dou u by dou x plus dou v by dou y. So therefore double integral over s dou u by dou x plus dou v by dou y into dx dy can be expressed as a line integral or integral along the curve C by using Green's theorem. So this will become integral over C dash u dy minus v dx. ഇനി C dash എന്ന് പറയുന്നത് that consists of this three curves, that is PA, AB and BP. Now let me evaluate the line integral along these individual curves PA, AB and BP. So we have this integral. So integral over C dash u dy minus v dx. That will be the value of the double integral. ഇനി അതിനെ എനിക്ക് integral over AB u dy minus v dx plus integral over BP u dy minus v dx, then integral over PA u dy minus v dx എന്ന് എഴുതാൻ പറ്റും. Okay. And now you can see that along PA y is equal to eta, and along PB x is equal to xi. So which are some constant values. Eta and psi numbers are, so these are constant values. So therefore dx will be equal to 0 along PB and dy will be equal to 0 along PA. So let me substitute those values into the line integrals. അപ്പോൾ ഇതിൻ്റെ അകത്തെ ഒരു ടേം വെച്ച് 0 ആയി പോകും. So along BP dx will be 0, and along PA dy will be equal to 0. So the line integral will simplify in the form integral AB u dy minus v dx plus integral BP u dy minus integral PDA v dx. And now we have integrals along, so u dy യുടെ ഇന്റഗ്രലും v dx ന്റെ ഇന്റഗ്രലും ഉണ്ട്. Now we know the values of u and v. So integral over PA v dx becomes, so substituting the value of v, we will get bwz plus w dou z by dou x dx. Now this can be split into two integrals. അപ്പോൾ integral along PA dwz dx വരും. Then integral along PA w dou z by dou x. Now let me just find the value of the second integral using integration by parts. So you will get first function into integral of the second minus integral of derivative of the first into integral of the second vary. So that will be in this form. From first function w, first function into integral of the second with respect to x will be z. Apply the limits along PA, then minus integral of derivative of the first will be dou w by dou x into integral of the second is z dx. Ni nammal limits apply cheyyumbom so the lower limit will be at p and upper limit will be at a. So limits apply cheyyumbom we will get wz at a minus wz at p, and combining these two, so z is common in the first and the last integral. So we will get integral along PA z dw minus dou w by dou x dx. And now let me substitute this integral into this equation. അപ്പോൾ നമുക്ക് അത് രണ്ടും സീറോ ആയി കഴിഞ്ഞിട്ട് കിട്ടിയ ഇൻ്റഗ്രൽ ഇതാണ്. അപ്പോൾ നമ്മൾ ഇൻ്റഗ്രൽ ഓവർ പി എ വി ഡി എക്സ് ആണ് കണ്ടുപിടിച്ചത്. സോ ലെറ്റ് മീ സബ്സ്റ്റിറ്റ്യൂട്ട് the integral value into this equation. Okay. So that is going to give integral along AB u dy minus v dx, then integral along BP. So this was u value. Integral along നമുക്ക് കിട്ടുന്നത് integral u dy. So I have replaced the value of u. Okay. So that will be awz minus z dou w by dou y dy. Then substitute the value of integral along PA. So we'll get minus wz evaluated at a plus wz evaluated at p minus integral along PAz dw minus dou w by dou x dx. So that is the value of double integral over s WL z minus z this is m w. Okay. Ini let us apply the boundary conditions to obtain the value of z. Ini we will be finding here what is the value of z at point P. നമ്മൾ ആ curve c dash define ചെയ്തിരിക്കുന്നു. So we have taken the assumption that the solution agrees at the point P. So we are interested in finding the z value at the point P. So let us simplify this expression using some set of boundary conditions.